Good day everyone, I am Frederick Salimi, Director of PMC Overall. This e-course will be uploaded in a training workspace of EPC 365. If you have any questions, please send us an email given in description. Have a good day and talk to you later. A brief description about my qualification and experience. I have a master's degree in dependability, which covers safety, reliability, maintainability, and availability. I also have a BS degree in process control and instrumentation. I worked several years with engineering companies like Technip and operators like Total. I was involved in pre-project, FEED, detailed design, construction, and operation. Today we discuss about functional safety. This is a generic version and will be customized later. This course takes 1 day and we give you 1 year access to EPC 365's training monitor. And this course, the objective of this course is to give a practical understanding of functional safety for oil and gas installation. So the objective is functional safety audits, FSA. The purpose of this study is to perform a functional safety assessment as per IEC 615081. We discuss about also functional safety management plan. And the purpose of this activity is to compile a dedicated document or requirement related to SIS, Safety Instrumented System. The SIA Functional Safety Management Plan provides the fundamental information regarding organization, planning, management, design, verification, installation, operation, and maintenance of SIS. It describes activities that will take place throughout the SIS safety cycle, from SIS inspection through decommissioning. And finally, we discuss also about the safety requirement specification, SRS. The objective of safety requirement specification is to define the required performance expected for each SIF. Now, the first one that we discuss is functional safety audit. So basically in IEC there are several the processes are here, and the scope of functional safety assessment audit is based on IEC 61511 clause 526. And it includes the output of the system safety requirements in a specification SRS, which is on clause 10. The result of, we have to look at the result of aerial activities, hazard and risk assessment here. Allocation to the safety function to the protection layer, which we give here about the SIF, and transverse activities performed up to the point, the management of the functional safety, and safety life cycle structure and planning, and verification. Here how we verify this process, and where relevant to the activities already performed, what the standards call functional safety audit. So I give you here in functional safety audit, the key points are: first, baseline. The FSA is performed on the basis of IEC 61511 according to this process defined in IEC 61508. The scope or safety function for the new equipment and their interfaces to the existing equipment, for which contractor is directly or indirectly responsible with other contractors. Independence, the FSA assessor tier is sufficiently independent from other auditors team perform safety studies for the project and customer. So this independence is important. Process, the FSA is conducted in several steps, which covers planning, reviewing, and available functional safety management documentation, and reviewing the functional safety technical and verification documents. So this is the process that we discussed in detail in our workshop. Follow-up, it is expected that the contractor will provide, after suitable improvement, a set of follow-up documents, so the auditor may produce a final version of FSA report where compliance to the baseline is assessed to be wholly achieved. Traceability, compliance to the standards is traced to the FSA report. And confidentiality of interview. In fact, there will not be the name of the people, no mention of what people may or may not have described to auditor in the interview should be made. And cybersecurity, contractor shall provide evidence that cybersecurity activities are covered. So these are the key points in functional safety audits. Now I go for the next topic, SIS Functional Safety Management Plan. So this, the purpose of this activity is to compile in a dedicated document all requirements related to SIS, a Safety Instrumented System. And SIS Functional Safety Management Plan provides the fundamental information regarding organization, planning, management, design, verification, installation, operation, and maintenance of SIS. An SIS Functional Management Plan describes activities that will take place through a SIS safety cycle from SIA concept to the decommissioning. For example, here from concept up to the decommissioning, all the activities will be explained in SIA Functional Safety Management Plan. So in SIS Functional Management Plan should structure the document with the following phrases: about hazard and risk assessment, allocation of safety function to protection layer, SIS safety system requirements specification, SIS design and engineering, SIS installation and commissioning, SIS validation, SIS operation and maintenance, and SIS modification and decommissioning. During each phase, the following should be carried out. Management of functional safety is organization, resources, competency, very important. Planning, safety action tracking, quality management, document and production tool, SIA performance, functional safety assessment and audit, and verification. Defined verification activities are carried out to ensure each phase is completed successfully. And in functional safety management plan, for each stage of SIS life cycle shall document as a minimum objective, IEC 61511 references, project references, task and activities required and plan, input and output. The document should also be prepared with a suitable detail level allowing follow-up of the activities. It may be necessary that the latter phrases, this document should be updated with input from vendors or documenting changes occurring in the project. And particular care should be also taken matching functional safety requirement at the interface between greenfield and brownfield system. and the contractor shall obtain relevant information for the brownfield references if required. So now we discuss about SRS, which is a safety requirement specification. The objective of SRS is to define the requirement performance expected for each SIF. You remember the SIF at the end of this e-course, there is a seal allocation. There is a list of our e-courses, and you look at this, and then you look at the SIF, and then for each SIF, an SRS sheet shall be prepared and will focus on function, availability, reliability, survivability, dependency, and this is performance standards. That means that for all these SIF, which are we have to consider as critical elements. So all these loops are elements, and we have to do the same procedure as we do create the performance standard. So the SR dossier will address in a generic manner the following. So here there are a list of this. I go through certain of them. Action on loss of power, field device, sensor, final element, logic solver, redundancy, de-energize to trip, software requirement, diagnostic, and logic solver response time, SIS manual shutdown and reset, action open, detection or fault. Here also there are certain other things, operator interface requirement, startup and maintenance inhibit, security requirement, common cause failure consideration is very important, especially trip rate, mean time to repair, environmental condition and interface between EST and SCADA if there is communication requirement. And the list of the control room and safety related alarms that took credit in the SEAL workshop report and to their requirement on the HMI. If any, identification of the dangerous combinations of output states of SIS that need to be avoided, and also survivability, as in performance standard you saw, survivability requirement necessary to survive a major accident event such as fire and explosion. So SRS safety requirement specification will be prepared. These are the things that has to be there. SIF description, logic narrative, seal rating, PFT required, list of IPL that to credit during SEAL workshop, SEAL allocation workshop. You can see in the SEAL allocation e-course, common cause failure assumption, safe state, demand rate. This is again in SEAL allocation you can see, proof test interval and implementation requirement. This is in SEAL demonstration or verification, response time, trip point, measuring point, SIF final element, functional relationship between input and output, inhibit requirement, spurious trip, and a specific action. So now I show you here, this is a table that for each SIF should be written. For example, initiating event, what is a hazard, for example pipe rupture, what is the consequences. These are from SEAL allocation. You can see there in the action sheet or action sheet of SEAL assignment or worksheet, safe status and required SIF action, proof test, and this is from SEAL verification, response time, and also mode of operation, MTTR, and trip mode, manual shutdown, no, availability requirement,
is 99.9%, and this is, you can take it from seal verification, duration of document references, and HAZOP, seal assignment, and PNIDs, EST, and any notes. So this is should go for any SIF than for SRS. So here I will show you, you can go, this e-course will be uploaded in SEAL, in risk engineering training, and when you click on SEAL, you will come to this page. If we, for the customized training, company will insert all the documents necessary related to SEAL, and we create a e-course, and when we created e-course, we put it in the discussion here, and the staff have the possibility to ask questions, or we answer their questions. Now I put a CSV video here, and here there was an accident which killed 15 people and injured more than 180 and billions of the dollar for the operator. So basically here the high level alarm high did not work, and I would like here you think about it, what was missing in SRS or functional management plan for this SIF, and then we will discuss it in our next workshop. Thank you for your attention. If you have any question, please send an email to pmc@epc365.com. We have two websites, one is French and one in English. You can send us, there is a request form, and you can ask your questions. We will get back to you as soon as possible. Thank you very much, and talk to you in our next workshop.
The hot feed entering the tower caused the liquid inside to start to boil and swell. Liquid filled the tower completely and began spilling into the overhead vapor line, exerting great pressure on the emergency relief valves 150 feet below. At 1:14 p.m., the three emergency valves opened, sending nearly 52,000 gallons of flammable liquid to the blowdown drum at the other end of the ISOM unit. Liquid rose inside the blowdown drum and overflowed into a process sewer, setting off alarms in the control room. But the high-level alarm on the blowdown drum failed to go off. None of the operators knew of the catastrophe unfolding in the ISOM unit. As flammable hydrocarbons overfilled the blowdown drum, operators nearby saw a geyser of liquid and vapor erupt from the top of the stack. The equivalent of nearly a tanker truck full of hot gasoline fell to the ground and began forming a huge flammable vapor cloud. The vapor cloud expanded in just 90 seconds, engulfing the unit and the nearby trailers full of workers. About 25 feet from the base of the blowdown drum, two workers were parked in a pickup truck with the engine idling. As flammable vapor entered the air intake, the diesel engine began to race. The two workers fled, unable to shut off the engine. Moments later, witnesses saw the truck backfire and ignite the vapor cloud. Powerful explosions swept through the area. The blast pressure wave accelerated through the ISOM unit, causing heavy destruction and igniting fires. The workers inside the trailers were right in the path of the explosions. The fires continued to burn for hours. 12 of the 20 occupants of the double-wide trailer were killed, along with 3 workers in a trailer nearby. 180 workers were injured, many with serious burns, fractures, or other traumatic injuries. The wood and metal frame trailers were blown apart by the blasts. Firefighters struggled to rescue the injured and recover the victims. 50 large chemical storage tanks were damaged, and the ISOM unit remained shut down for more than 2 years.